This is carried on with some probability techniques, but links more to some rules that we can use in relation to combined events, mutually exclusive, independent, and conditional. So first of all, we're going to look at combined events. If you want the probability of either event A or event B or both occurring, you can think of this as the union of these two sets, the A or B. So in a Venn diagram, as you can see there, all the circle parts shaded in. That is the A union B within a Venn diagram. Simply adding the probability of A to the probability of B will actually count the intersection, the A and B in the middle, twice. Therefore, with that information, we can use this rule to find the probability of A union B happening. So the probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. Quick example, if the probability of A equals 0.4 and the probability of B equals 0.3, and then the probability of A or B equals 0.5, find the probability of A and B. So all we need to do here is just use the rule. So we know the probability of A or B is 0.5, so we'll have 0.5 equals probability of A 0.4 plus the probability of B 0.3 minus the probability of A and B, which is what we're trying to find. From here, we just rearrange that and solve for the probability of A and B. And if we do that, we will end up with 0.5 equals 0.7 minus the probability of A and B, rearrange that, and we will end up with probability of 0.2. So therefore, the intersection, the probability of the intersection is 0.2. Now, one thing I'm going to tell you with this rule is I would recommend always using this rule, no matter what the situation is. Next, let's look at mutually exclusive events. So two events are mutually exclusive if they cannot both happen at the same time. So for example, throwing a 1 and a 6 on a dice. We can't do that at the same time. We can either throw a 1 or a 6, but we can't throw both. And a quick rule, if A and B are mutually exclusive, then there is no intersection, that's just 0. So the probability of A or B would then actually just be the probability of A plus the probability of B, which means we don't need to minus the intersection because the intersection would just be 0 anyway. This example, if two events A and B are mutually exclusive and the probability of A equals 0.5 and probability of A or B equals 0.8, find the probability of B. So using that rule there, probability of A or B is 0.8. That would equal the probability of A plus the probability of B, which is what we are finding. Solve that, and then really easy, the probability of B must be 0.3. Now, once again, if you're not sure if something's mutually exclusive, just use the formula from before, the combined events rule, because that will still work if they're mutually exclusive, because the intersection would just be 0. So it's one of those things, that first rule that I showed you is the most important because that will still work for all these, for mutually exclusive and independent events. Next, we're going to look at conditional probability. So if the probability of event A happening is dependent on a previous event B, then the probability is conditional. So we have this rule, and it's a probability of A line B. How we say that is a probability of A given B. That's what that means. So the line basically means given. So in the wording here, so it's A given B. And the formula for that is a probability of the intersection of A and B divided by the probability of B. This is another important rule and a really good rule to make sure you know how to use. In exams, it does come up quite often. A pack of 52 cards contains 13 hearts. If the first card taken from the pack without replacement is a heart, what is the probability that the second card will also be a heart? So our formula here, don't have the word of given in there, so we've got to recognise ourselves that this is a conditional probability question. And we would have the probability of a second heart, so we get heart on the second, given that we got our first card was a heart. So the probability of a second heart and the first card being a heart can be worked out by doing multiplication of it. If you think about it as a tree diagram, the first heart would be a 13 out of 52 probability. Then because we haven't replaced it, our second would be the probability of getting a heart a second time would then be 12 because we've already taken one out, and out of 51 because we've already taken one card away and we haven't replaced it. So that would be our numerator. So 13 out of 52 times 12 out of 51 we divide by the given part. So in this, the given is that we first had a heart. So the probability of getting a heart first was 13 out of 52. You figure that out, work that out, and we end up with 12 out of 51 for our probability, which simplifies down to 4/17. So let's look at another example. So the probability of a randomly chosen student studying only French is 0.4, and studying French and Spanish is 0.1. Find the probability of a student studying Spanish given that they study French. This question, we've got the probability of Spanish given they study French, which means our rule would then be we want the probability of Spanish and French over the probability of French using the rule. Now, Spanish and French. Now, if we think of this in a Venn diagram situation, we've got French and Spanish. We know that French and Spanish is 0.1, so that would be in the intersection, and studying only French is 0.4, which would be this part of probability of Spanish and French is the intersection, which is 0.1. Now, the probability of studying French is the whole circle of French, which is 0.5. Now, remember, we can't leave decimals in fractions, so we'll simplify that, and the answer would be 1 out of 5, or 0.2, depending whichever your calculator gives you. But in this situation, it was good to draw a quick sketch of a Venn diagram so we can see that the probability of the given part, the probability of French for the denominator of the fraction, was 0.5, not 0.4, as I think a lot of people would do in this question if it was in an exam. Lastly, independent events. Two events are independent if one doesn't affect the other, and the rule for that is the probability of A and B equals the probability of A times the probability of B. Now, the biggest thing, as I've been saying throughout this video, is you cannot assume things are independent or mutually exclusive unless the question tells you so. The probability of an individual in a group being male is 0.52. The probability of the individual being Irish is 0.18. If these are independent, find the probability that a chosen individual is a male of Irish origin. In this question, we are told they are independent, which means we can use the rule above to work out the probability of male and Irish origin. So probability of being male was 0.52, multiplied by the probability of being Irish, which was 0.18, which gives an answer of 0.0936. That's the end of this video on probability.